In our mental construct, the color brown of this table, the relationship of the color brown with this table is the same as the relationship of knowledge to the Atma, because they are gunas of some dravya. So it is creating a layer of abstraction for us, Navya Nyaya, is in which we can associate, we can think in terms of relationships which go across very diverse things. In English language, knowledge is used also for stored knowledge as well as I am knowing something right now. Both are knowing as a verb is used for both. There is a clear distinction in Nyaya. Gyan is what I am having right now, cognition, and Sanskar is what is imprint from a previously had knowledge, previously had cognition. So I would like to use the word cognition for Gyan and Sanskar for memory. For being able to do all of this, what we require is a non-ambiguous language. And Paribhasha is a Navya Nyaya Paribhasha which Gangeshopadhyay invented in 13th century, 12th, 13th century. Paribhasha is meant to unambiguously describe any Gyan. I'm going to just zoom out and say what has been the artificial intelligence journey so far. So we roughly put it in 3 parts. Since before 1980s, there were experimental approaches tried for replicating a lot of human intelligence in machines, but hardware was not good enough. The second phase is when people thought that manipulation of symbols can achieve intelligence. This is the phase till, you can say, 2012. And knowledge representation was at the center, and formal logic. A lot of logic and reasoning talk has gone all day. That this era was the focus of formal logic. Then in 2012, Geoffrey Hinton invented deep learning, because of which the primary sort of assumption of this era is that recognizing patterns in large data sets can achieve intelligence. And machine learning is at the center, and vector-based algorithms are what are encouraged. Since 2012, what has happened is, again, can be divided into sort of 2 parts. Geoffrey Hinton invents deep learning, and then there is non-generative learning-based AI. Before 2017, before LLMs, a lot of success in computer vision and OCR, speech to text, but was not succeeded in natural language understanding, which happened after 2017. There was a paper called Attention is All You Need. This is the paper which defines LLMs. And then there was substantial success in automated code generation, image, video, and natural language generation. Now, there are still unmet expectations from generative AI. So the name of my talk is Limitations of Generative AI. These are 3 things. Despite its stellar success, it is sort of a victim of its own success. The first is enterprises expect far more reliability and predictability. Okay. The second is regulators and compliance professionals expect proper reasoning and explanation backing the responses. What we have heard along the day, that is not happening. And the third is developers and product managers expect learning on the go. The basic problem is, let us say an LLM gave you a wrong answer, you corrected it and told it this is wrong. It doesn't learn next time. It will repeat the same mistake again. The backend training has to be changed. But even after these limitations, there is success of LLMs have shown something very important, which is there is something latent in the structure of natural languages that helps machine perform cognitive tasks and communicate about the real world. This is an aspect sort of missed during the day because it's not a Vyakarna discussion. It was more of a Nyaya discussion. All of people are talking about logic. But there is something about the structure of natural language itself which has cognition inbuilt in it. Something that the symbolic formal logic could not do. The pre-2012 symbolic AI did not succeed. It failed because it was not able to deal with all the human complexity. Too much structured logic. So there is something that a symbolic formal logic was not able to do, and there is something that vector-based representation can do, but not in a reliable, explainable way. So that brings us to the fundamental question: what is it about natural languages that is able to express reality better than vector-based expressions and reason about it better than formal logic? Now, this is the fundamental question which Nyaya answers to some degree, according to me, basically. There's another way to put this question. Is there a deterministic way of representing and reasoning about the human world, which, with all its complexity, which is not probabilistic, which is not generating random text, which is deterministic, which means that given a question, you can determine the answer. And it is able to represent all the complexity of the human world, which is the same question as saying, what is it about natural languages that is able to express reality better than vectors and reason about it better than formal logic? So this is a research startup I run, Acquired Lang, which has now completed 8-year-long research. We have a demonstration to show of a computer language which is roughly based on Nyaya's logic. There are 3-4 more things in it. also borrowed from Vyakarna and some bit of Mimansa. The rest of this presentation gives glimpses of principles from these sciences useful in computer science and AI. This is my favorite thing, that somebody said world is made up of stories. The second is no, the world is made up of atoms. The first one says that's just one story. Okay. So, okay, that's why worldview matters. So we have to start from completely else to understand why is natural language able to express reality. So this is the first postulate we borrowed from Nyaya. The world is not made up of atoms. World is made up of meanings of words. This is the first postulate of Navya Nyaya that we got and which we said that we will use in computer science. The second is knowledge in the human mind is composed of meanings of words. This is not an obvious sentence. If you think about it, we visualize things as pictures. People say we have pictorial memory. Artists have memories in their brush strokes and their bodies. But Navya Nyaya says that knowledge, for the purpose of logic application at least, is in terms of meanings of words. So there is modern research on it also about neurological system, that it takes 128 milliseconds to complete a conceptualization, to associate a word with a phenomena. So a conceptualization at the end of it has a word associated with something, and if it is not a Padartha. It's Padasya Artha primarily, basically. It has to be meaning of a word. The fourth is a constrained subset of a natural language can be unambiguous. Everybody says that natural language is ambiguous, right? And that is why we require this learning and all of that, because logic cannot be applied. And we say, no, there is, in Navya Nyaya, there is a subset of Sanskrit language, which they call Paribhasha, which is non-ambiguous. So these are the three things which I am going to say are the primarily borrowed concept from Navya Nyaya. There are other concepts we have borrowed from Vyakarna, etc. But from which roughly map onto ontology, epistemology and representation, which we say Padartha, Gyan and Paribhasha. I'm going to go into each one of them and how they are useful to computer science. I'm going to skip those part of these things which have already been covered. Literally meaning first artha, it's basically conceptualization is what it is. This is the sentence I was saying. Prashastapad says, Astitva, Abhidheyatva, Geyatva. Existence, nameability and knowability. What we know has a name and exists, basically. All three other properties of the same thing. Sapta Padartha, people have been talking about this since morning. There are 7 Padarthas which are there. All meanings of words fall under these 7 categories. They have further subcategories. There are 9 Dravyas, there are 24 Gunas. Out of them, roughly the first 3 are what makes up, quote unquote, the real world. Everything that we sort of perceive, Dravya, Guna and Karma can sort of take care of them. The rest are more definitional. They are sort of created, is a wrong word basically, but they are not, they are something which are required to explain how we think more than what the real things are. I'm going to skip this through thing, but this is an important aspect. Inside Dravya there are Murta and Amurta. There is Prithvi, Jal, Tej, Vayu, Man, which is Murta. There is Dik, Kal, Akash, Atma, which is Amurta, which is basically space, time, consciousness, and Akash is untranslatable again. But the fact is, this what it allows us to do. These definitions which I was showing was saying that gunas are something which properties of a dravya. What this allows us to, the structure of putting 7 kinds of meanings allows us to do, is to say that there are gunas of Atma. Jnana, Sukha, Dukha, Ichha, Dvesh, Prayatna, Dharma, Sanskar. The last row are the gunas of Atma. So how what it's saying is that in our mental construct, the color brown of this table, the relationship of the color brown with this table is the same as the relationship of knowledge to the Atma, because they are gunas of some dravya. So it is creating a layer of abstraction for us, Navya Nyaya, is in which we can think in terms of relationships which go across very diverse things. So in a way, Padartha is providing us an ontology, basically, which is so exhaustive that, and it has been evolved over 2500 years, so that at the end of the day we have Sanskrit koshas in which there is a Padartha Vibhag for every word. Every Sanskrit word in the dictionary can say that in this category of 7 Padarthas and there are further categories, where does a word find? It's impossible in English, by the way. There have been attempts. There is a categorization version of Roger Thesaurus. They had 145 categories to start. We have 7, basically. So this ontology has a place. So the objection he was raising is basically this, that there are 3 things. There is Padartha, there is Gyan, and there is Shabda. Gyan is something that happens inside us, insights to the Atma. Padartha is there, outside in the world, and word is what it means. So this ontology has a place for words and knowledge and phenomena, with clear distinction between them and the relationship between them, because of which human faculties are also covered, because of which there are I seeing somebody else is having knowledge is expressible. I have the knowledge that somebody has a knowledge is expressible, basically. Vishayi bhav is another thing, is about basically the relationship between knowledge and the thing of which the knowledge is, has also been clearly mentioned. So this allows us to have an ontology which deals with all of them without escaping. Right now, there is a whole, in computer science, there is a whole confusion about I model something and I treat the model as the real. I say I call a function on an object. That distinction is lost in my head. Okay, so why is this Padartha first postulate important? Because if you look at computational logic from Nyaya's view, this has been repeated by many people, by the way, so earlier before me, that the form of the logical discourse is abstracted out from its content in the West. What it means is that primitives of computational logic are propositions, logical operators, predicate, quantifiers, all deal with form of the discourse. If there is a sentence I make, what follows from that sentence. They are useful for writing precise rules of deriving new knowledge from existing knowledge, but provides no structure for the content of the knowledge itself. Whereas there is nothing called padarthas. The 7 types of meanings, the things that make, that is what it basically means. Because, and what earlier Guha sir was saying, that that's why there is no attempt at expressing what is real, what is true. It's all abstracted out, basically. So all, in short, epistemology independent of ontology. Can an ontology represent everything? The usual answer is no. Because the modern science implicitly assumes a hierarchy that starts with maths, then physics, then chemistry, biology, psychology. And mathematical and physical constructs are not good enough to build the entire knowledge base. Whereas Padartha has meanings of words, which is horizontal. You have meanings from all fields. You don't start by building from the primitives up. And even for what they call emergent phenomena, have similar relationship with the primitive phenomena, basically. So that's Padartha. That's why the ontology is what we can get from Navya Nyaya. The second is Gyan, epistemology. So I'm going to skip this very far because I have been already told. Basically, there is a distinction in Nyaya makes between Gyan and Sanskar. In English language, knowledge is used also for stored knowledge as well as I am knowing something right now. Both are, knowing as a verb is used for both. There is a clear distinction in Nyaya. Gyan is what I am having right now, cognition, and Sanskar is what is imprint from a previously had knowledge, previously had cognition. So I would like to use the word cognition for Gyan and Sanskar for memory, but knowledge is a word which is confusing in this regard. I'm going to again skip this. Smriti Anubhav Yathartha has been told many times by the earlier speakers. Basically, what you recall from earlier is Smriti. What you are having right now is Anubhav. Yathartha is valid. Yathartha is invalid. Okay. Thus, this one thing is there is a Navya Nyaya further postulates that every cognition can be canonically represented in terms of 2 padarthas connected to each other by a Sansarga. There are canonical names for them. They call Prakar, Sansarga, and Vishesha. When I say Neel Kamal, Neel is what is that which specifies, Kamal is that which is getting specified. And they have these canonical names. And there is a direction of that arrow. This allows Anuman. All that talk we are having about, the basic thing about it is that there is smoke on a mountain. And I can conclude that fire is also on that mountain. This is the paksha, this is the hetu. The hetu contains the arrow. Dhumavatvat, the virtue of being dhumavan. Basically, that the arrow is included in the thing that is inferred, and this arrow is the sadhya, basically, with the arrow. Now, the thing is that this and this relationship is Vyapti. That wherever there is smoke, wherever there is smokiness, dhumavatvat, has to be, there is fieriness. Such a repeated pattern observed earlier is called Vyapti. All learning is Vyaptigraha. Whatever we have learned from childhood is basically, we have learned associations of 2 things together. Except for learning about the meaning of a word, which is upamana. Basically, that you associate that a thing on which you sit with the back is called a chair. There is no anuman in it. There is no Vyapti happening here, but there is remembering of a name basically happening. Now, this is what this tells about this structure of this Gyanakar, how Nyaya presents Gyan, is that it allows for inductive knowledge to be represented. If you look at this era-wise split that we did for AI earlier, The deterministic era was purely deductive, and the probabilistic era is purely inductive. Induction is basically that from something being true for or earlier entries, you assume it will be true for the following entries also. So the machine learning is basically inductive. It sees patterns, it learns it, like throws out the same pattern again. Yes, neuro-symbolic is basically an attempt at mixing these two. That is why there is an impedance mismatch between the two. There is a mismatch which is not clear basically. And so the mismatch can be overcome with Vyaptigraha as induction. Not predicting the next para, but predicting the existence of a sadhya in a paksha given a udharan. There is possibility of creating learning algorithms which does Vyaptigraha, which says that wherever this thing with a relationship is in A, another thing can be concluded. This pattern has to be learned, not just what the next para is. That's and Sansarga is that bridge basically. That the Paramarsha, that diagram of Vyapti, I showed all these aspects, Vyapti, Sadhya, Hetu, Paksha, that depend on the Sansarga. That idea that there is a three-part thing. And it can be learned, and it's not ontological. These primitives are epistemological primitives, and Navya Nyaya binds them together. I am going to quickly finish the last section. This is the last section. Paribhasha. For being able to do all of this, what we require is a non-ambiguous language. And Paribhasha is a Navya Nyaya Paribhasha with Gangesha Upadhyaya invented in 13th century, 12th, 13th century. Paribhasha is meant to unambiguously describe any Gyan. An example is Ramaha Gramam Gacchati's Ekatvavachinna Grama Nishta Sanyoganukula Vyaparanukula Prayatnavan Ramaha. That Ram which makes the effort, that causes an action, that results in a contact with a village that is limited by oneness. This is a canonical representation of the simple line Ram goes to a village. Okay. But what it does is that it clearly puts the different padas and their arthas and relates them by clear arrows. This is an example of a paribhasha. It can be very complex. Paribhasha can describe a knowledge whose vishay. So if I know Ramah Gramam Gacchati, this has to be described. Then my Gyan, first object is me, second object is my Gyan, third object is this vishay, which is that Ram which causes this. So it can be infinitely nested. Now, there are features of Paribhasha. The first of it is well defined. Provides an exhaustive set of Sansargas, cognitive relations, such as property, locus, cause, effect, limitation, indication, equivalence, distinction, etc. Provides rules of what type of Padartha can enter what kind of Sansarga. That Neel and Kamal ke beech mein gun-guni sambandh hai. It is clearly defines what can be related to what. Thus, Paribhasha helps formalize the notion of a meaning of a word as a well-defined object with a well-defined behavior. The second aspect is it facilitates application of logic. Now, which we have roughly discussed earlier, but we intuitively know that a crimson car is a red vehicle. Okay. Now, in a Paribhasha, would translate a crimson car into a dravya having carness limited by crimsonness. This is my English attempt at Paribhasha. Okay. A red vehicle into a dravya having vehicleness limited by redness. Okay. Now, because a vehicleness can be inferred from a carness and redness can be inferred from crimsonness, hence the meaning of two phrases can be compared. Now, the Paribhasha allows us to do this for arbitrary depth with all its complexity. It allows us to do. That is why there are clear-cut rules of applying logic given a Paribhasha. This idea of A-ness being inferred from B-ness is called Vyapti. We have discussed this earlier. Okay. It serves as a language of comprehension. The third is that the fourth pramana, verbal testimony, acquiring knowledge through language, involves a process of comprehension called Shabdabodh. It postulates that meaning of a sentence is made up of meaning. Thus, Srinivas just now said this, made up of meanings of constituent words. Further, there are laws of Shabdabodh which determine which syntactic structure of Sanskrit language generates which kind of Sansarga and Padartha. And Vyutpattivad is a book written by Gadadhar Bhattacharya in 18th century which elaborates rules of comprehending every possible Sanskrit utterance into a graph of submeanings. He has written down Avada Grantha. It is the final word of, you can translate every Sanskrit sentence into a graph like this. I think that is it. That is my conclusion on this.